No, second. I gave it to you last week. Mean value theorem? You got it? It's going to take a while. Do I need to print more? Got it? No? I can print more. Yes? Alright, so continuing what we're working on. Mean value theorem here. Alright, so let's get started. So, class. I get one yes. Sound more confident. Neff. Okay, good. Anyway, so the whole thing of what we were talking about is that the derivative in mean value theorem is equal to the slope, the secant line. So what I'm going to do here is apply mean value theorem to this problem. Use mean value theory to show that the car travels at 110 miles in 2 hours. Must have a speed of 55 miles per hour. At least once during the time. Okay. So, let's say for instance, I have distance over time. Mean value theorem says that f of my ending, which is going to be 2 hours, minus f of my starting, which is how many hours? How many hours does it start? 0, right? Okay. Should be equal to 2 minus 0. So at the end of 2 hours, how many miles did it go? 110, right? Minus, at 0 hours, what distance did it go? 0 over, and this is for my secant line.
What does that say?
Huh?
What is the number?
What's the number? 55? Sorry, my penmanship is not good on this board. So there's my slope for my secant line. So after my 2 hours, we ended up at 110 miles. Something like that. So my secant line right here, so my mean value theorem says that at some point when we're driving this, we started at 0. We started at 0, right? So in your car, you get into it, put in the key, push your foot on the gas, and you go vroom vroom, right? So if I start at 0 miles per hour and I somehow end up traveling 110 miles, the average velocity is going to be 55 miles per hour. Have you guys ever been on a trip? In that trip, you go any place long distance? Where'd you go, Sherilyn?
To Sequoia.
Huh?
Sequoia National Park.
I almost understood.
Sequoia National Park.
Oh, Sequoia National Park? Okay. And what happened within the first 2 hours on that trip? Oh, okay. What normally happens, especially with my wife, within the first hour, we have to take our first restroom stop. Okay, so if I stop a couple times, so that means what? Am I going, if in 2 hours I ended up 110 miles away, did I drive 55 miles an hour the whole time? No. Would I have to go more than 55 miles an hour for some of it? Okay, but yeah, for all those stops that we did, so somewhere this might actually be, might go like this. So distance, there we go, distance might look like this. This is supposed to be straight, not here. We don't go negative distance. Unless we had to go back to the restroom that my wife just left, where, you know, I have to go back because she left her phone in the bathroom. That has been done before. So, stuff like that. So, we ended up going the distance and wasting some time here, wasting some time here, but we still ended at 110 miles. So somewhere in between, or multiple places in between, that this has to be 55 miles per hour. So that's what that means. So there has to be somewhere in there. I can go more, go less, but it averaged out to be 55 miles an hour. Because that's what my secant line told me. Does that make sense or nonsense? Does the story help? Because yes, I'm traveling, and yes, I know on a long trip I'm never going to actually make it all the way there without making 2 restroom stops. So, anyway. Mean value theorem. If f prime of x is equal to 0 for all numbers within there, then f is a constant on the interval from a to b. Okay. If a function, the corollary, if a function is continuous on the closed interval from a to b and is differentiable on the open interval from a to b, and f prime of x is equal to 0 for all numbers within the x, then f is a constant from a to b. So, what does that mean? Start with this part right here. What would the graph look like? Would the graph look like this? Yeah. Because the slope would be 0 for all points in between that interval. So what this means is constant number. So if I just have a constant, if y equals 5, then it would look like this. If an object in rectilinear motion has a velocity of 0, then the object is at rest. So if this is distance over time, my distance, is the distance increasing? Distance is not increasing, is it? Is time increasing? Yes. So if it's not going forward or going backwards, but distance is over time, and time keeps happening, so it's not moving. It's sitting there. That's what that means. So velocity is 0. So that means it's not traveling at all, but the time still goes. If the function f and g are differentiable on an open interval a to b, and f prime of x is equal to g prime of x for all numbers in x, then there is a number c for which that f of x is equal to g of x plus c on the interval. That's important, that plus c part. C refers to just some constant number. In words, if two functions f and g have the same derivative, then the functions differ by a constant, and the graph, if f is a vertical shift of the graph of g. Now, there's another word for this. There's another word. Anyone tell me what that word is? That the lines are going to be... Yep. The lines will be parallel. They must be parallel. So if they have the same slope, that means the derivative is the same. So example would be y equals 2x plus 5 and y equals 2x minus 1. Those are not the same lines, are they? They're not the same lines, but they have the same slope. So therefore they are parallel to each other. So if I take the derivative, this one here would be y prime is 2. Y prime for this one also is 2. But they were not the same original functions. And that's what this means, that there is some value of c that they are differentiable. And they are different from each other. Corollary first derivative test. Let the function that is differentiable in the open interval from a to b, if f prime of x is greater than 0, what does that mean? It's doing what? It's increasing, right? The slope is positive, so it's going to be going up. Slope is positive. Then f is increasing from there. Okay, that means positive slope. If f prime of x is less than 0 on that interval, then it is decreasing. So this is a negative slope. Negative slope. Using first derivative test, you determine open intervals on which that the derivative is positive or negative. Suppose it is continuous on a closed interval a to b and differentiable on the open interval from a to b. F prime of x is greater than 0 on the interval, increasing on the closed interval a to b. F prime of x is less than 0 on it, is decreasing on the closed interval. And the first derivative test is valid in the interval, is right here. So from negative infinity to b, or a to positive infinity, or from negative infinity to infinity. That's what it's going to be valid. So now, if it's positive over the entirety, it would be the entire f is going to be there. This one is referring to that there's a point in which that it is going to be stopping at b, so it would be, so if it's increasing, so if we're looking at it increasing, that would be from negative infinity to b, and then again increasing wherever it comes up again. I know I'll use this as the example to go along with this. Is increasing, where is it decreasing? So we're going to take the first derivative test. So we need to take the first derivative. F prime of x is equal to 6x squared minus 18x plus 12. Factor out a 6. I'm left with, what's that going to be? That's going to be 2, 3, so negative, like that. Okay. Divided by 6. So this is going to give me 0 equals x minus 2, x minus 1. So where it's equal to 0, I'm going to have x equals positive 2 and positive 1. So on a graph, I'm going to start with those points there. Those are points in which that it's going to be equal to 0. So at positive 1 and positive 2. Positive 1 and positive 2. So this is going to be the graph of the derivative. Right? This is my f prime of x. So there's places in which that it is going to be equal to 0 there, and there. Let's test numbers to see increasing or decreasing. And my f prime of x was, let's see, plug in right. Let's plug in here. If I plug in 0, that would give me negative 2 and negative 1. So multiply those together, that would give me a positive 2, right? Okay. So that means that right here, so f prime of 0 is a positive. So that means that this is positive. So on this side, it's above the line. Next one. In between, that would be like a 1.5. F prime of 1.5 so if it's 1.5, that would be a negative, right? That would be a negative 0.5. Over here, this would be a positive 0.5, wouldn't it? A negative and a positive gives me a negative, right? So that means that the next part here is negative. So that means that this is going to be down here, and it's going to have to be coming back up like that for it to be 0 again. But is it going to bounce? Is it going to go up into the positive on the other side, or is it going to bounce back down? So let's check it again. Let's check it again at the next number, which would be 3. F prime of 3. 3 minus 2 is 1. 3 minus is 2. So that's positive, positive. That's going to give me a positive. So that means that this has to go back up this way. On my intervals, it is increasing. So it's increasing from the interval of negative infinity to where? To 1, right? Closed. And it's picking up, increasing again at 2. And it's going to positive infinity. It's decreasing from 1 to 2. And all this right here is from my first derivative test. So step by step, what was the first thing I did in this problem? Take the derivative and set it equal to 0. Take the derivative, set it equal to 0. What is derivative equal to 0 give me? Critical points. Very good. So that gave me these critical points right here. right there, and there. So I could actually use that on my number line and plug in numbers for my test. Okay. Did I answer everything? Increasing, decreasing? Is increasing, decreasing. So, determine where the function is increasing and decreasing. So first thing, I would like for you guys to try this using the same steps. All right, we just said the steps, so do it. I'll go over it. All right, so on this one here, let's do the derivative. So f prime of x is 2/3 x squared minus 1 to the negative 1/3 times 2x. F prime of x is equal to, put it together, 4x over 3 quantity x squared minus 1 to the positive 1/3. Now, critical points. Critical points. Does it always have to be factors? It doesn't. Critical points are also what? Undefined, right? Any place in here that it's going to be undefined. At 1, right? At 1, it's going to be undefined. Any other place? 0. It's cube root. 0 is okay. There's one more place. What happens when you square a negative? Square a negative becomes positive, isn't it? Yeah? So would negative 1 squared work also? Okay, so that means that I cannot have 1 or negative 1. So 1, it's going to give me 0 inside right here. Negative 1 is also, when I square that, is going to give me 0 right inside there. And I can't have 0 in the denominator. So those are my critical points on this one. And what else do we get?
0. Actually, that's
Yeah, it's also going to give me a 0, right? So x is going to be equal to 0, because once I clear out the denominator, right? So right now I already know that x cannot equal 1 or negative 1. Multiply both sides by the common denominator, and I get 0 equals 4x, and x equals 0. So I have 3 places on this one. So for my graph, I'm going to start by graphing this. So those are my critical points. Right there. And now I'm going to check those critical points. So one number, so I want to go, my f prime of x is 4x over 3 quantity x squared minus 1 to the positive 1/3, right? So I want to plug in numbers to the left and to the right. So this one right here, it's going to be a pain, but let's try number negative 2. So f prime of negative 2. So right here, if I plug in negative 2, that's going to give me a positive in the denominator. So that is going to be 4 minus 1 is 3, cube root of 3 times 3, 3 red 3, over like that, 3 cube root of 3 over 4 times negative 2. So all I need to know is the sign of this. I don't need to know what it actually numerically comes out to be. I just need to know, is it positive or is it negative? Positive numbers are my increasing. My negative numbers are decreasing. So right here, this is going to give me a negative, isn't it? Okay, so I get a negative right there. So negative there, because right here, that's squared, that became a positive, so there we go. So this one right here is a negative. So f prime of negative 2 is negative. So my line is down here. All right, plug in a negative 0.5 or negative 1/2. I like fractions. So that's going to be a positive 1/2. It's a negative inside the radical. So it's a negative inside the radical, so but that's going to give me a negative on the bottom. Because the cube root, I could have a negative. So I have a negative on the bottom, and on the top, because I'm plugging in a negative, I have another negative. So 2 negatives is going to make that one a positive. That means that's going up. Next one, f prime of the other side positive 1/2. So it's either going to go right here or continue back down. It could bounce and go back up.
Wait.
Huh?
Negative 1/2, still negative slope? Because the top
Negative's on top. Do you want here? I'll write it. So 4 times negative 1/2 over 3 Okay, on the top, I'm going to get a negative, right? On the bottom, because this is going to become a positive 1/4, right? That's positive 1/4 minus 1. So it's a negative 3/4. And because this is a cube root, I'm allowed to have a negative. So that's going to give me a negative, right? So a negative and a negative down here on the bottom. So the two negatives will make that one be a positive. All right, so positive 1/2. So if I do the same thing again, but this time with positive, if I change this to a positive like this, the bottom is going to stay the same as the negative, but the top is now going to be a positive. So that means that this is going to become negative, so that means that right here, at this critical point, it's going to come back down. And now I need to check something on the other side for like positive 2. So positive 2. Positive 2, I plug that in. I'm going to have a positive on the top. I'm going to have a positive on the top, but on the bottom, let's see. This is going to be a positive. 2 squared is 4. Minus 1 is 3. That's a positive. Radical 3. So that means that this is also going to be a positive. So that means this goes up this way. So from my graph, it is negative, so it's decreasing from negative infinity to negative 1, and it's decreasing again, so that's a union from parentheses 0 to positive 1. It's increasing where it's positive, that would be from negative 1 to 0, and again, union from 1 to positive infinity. Yes, no, maybe? Did I just say too many words? You guys need some time to digest this. The coffee hasn't came in yet, right? Is that what the problem is? Maybe? Question? Kind of zoned out there. You alright?
No, I wasn't zoned out. I was just trying to like process some of it.
Are you okay with this? Or like,
I mean, I'm okay with all that. Only part I like you lost me on the first one was like in the very beginning when you put like 0. I think it was x equals 4x and x equals 0. I was just confused on how you got that.
oh, okay, right here. Watch this, watch this. 0 equals 4x over 3 quantity x squared minus 1 to the 1/3. What's the common denominator? That's an equal sign right there. All this, right? Okay, this y love 0. Multiply both sides by this, right? Anything times 0 is,
0.
what's going to happen over here on the right hand side?
Cancels out.
And I'm left with 0 equals 4x. That's why when I do the factoring and stuff, I set it equal to 0, and then when I was looking at your notes when you were doing this, you still had it as a negative exponent.
Yeah.
So if you clean it up, put it back in the denominator, you could see, oh, right here, 0 equals all this. I can clean this by multiplying both sides by this. But this, if you see it that it's in the denominator is also cannot be equal to 0. So all this right here cannot be equal to 0. So that should be one of my rules for my critical points. That's what I need to look for.
Okay.
Is that better?
Yeah, that's good.
All right, questions, concerns, complaints, conspiracy theories. Go ahead, Vincent. You have a conspiracy theory? No. Okay. All right. Like, share, and subscribe. I'll let you guys work on this and do some homework.